All right, 7.2 part 2. We're going to continue with properties of exponential functions, but we're not graphing them anymore. We're going to use them to solve equations. So lucky for us, our equations in this section are actually going to be the equations we write, because it's going to be word problems. So we have to come up with the equation. So we have this formula for exponential growth and decay. So where A is our initial amount. So that's what we start with. It'll tell us you start with this much. So that's our A, initial amount. Our rate of growth is R, so it's a rate. We're usually going to see it as a percentage. If it tells us that it's increasing, it'll be a plus. If it tells us that it's decreasing, it's a minus in the middle. So that plus sign in the middle could change. So the percentage is our rate, but we always have to change the percentage to the decimal version. So if I have 25%, what's the decimal version of 25%? 0.25. So we move the decimal 2 times. So this would be 0.25. What if I had, let's say, 8%? What's the decimal version of 8%? 0.08, because remember, you move the decimal 2 times, so it'd be 0.08. So that's our rate, R. It's always the decimal version of it. And then T is that thing in the exponent, and it's the time. So usually it'll be years, but there's an example from the homework that says hours, so it's the time. So example 1 says, you invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? So our formula is A times 1 plus R to the power of T. A is our starting amount. R is the rate. And T is time. So what is our starting amount? 1,000. It says you invested $1,000. So that's how much you start with. What's our rate? 5%. But what's the decimal of 5%? 0.05 or 0.05. And then what's the time? 6 years. So once we find A, R, and T, we can plug it into our equation here. So we have 1,000 times 1 plus the rate, so plus 0.05 to the power of 6. Now here's where we need the calculator. What do you think I have to do first here? The parentheses. So 1 plus 0.05 would be 1.05. What do I do next? The exponent. So it would take a really long time to do 1.05 to the power of 6. So we are going to put that in the calculator. Now there's a couple different ways that we can put this in the calculator. So calculator. If you're using your phone calculator, you would put 1.05 and then there's a X with the power of Y. So it's a little exponent button like this. You click that button and then 6 and then equals. If you're using a calculator, some of them have 1.05 and then you would use the little, it's called a caret, that up arrow, and then 6 and then equals. And then also there's some calculators that have, I think it looks like this, 1.05 and then it has X and then a little box up top, and then you would click 6 and then equals. So every calculator is different. That's why it's important to use the calculator that you're going to use for the test. So if you don't have a calculator, use your phone or your iPad calculator for now, but you're not going to be able to use your phone or your iPad calculator for the test. So do the homework with the one that you're going to use. So make sure you know how to use your calculator. So these are all different ways to put it in the calculator. Ways to calculator. So 1.05 to the power of 6. When we put that in our calculator, we get 1.340095. And it keeps going, but I'm just going to round it to that for now. Because we can keep that in our calculator, and then the last step is to do what? What do I do with the 1,000? Multiply it by 1,000. So just keep it in your calculator, and then click times 1,000.
So how much numbers do you put it out?
You can write down as many as you want. Your final answer, you have to round it to 2 decimal places. So for my final answer, it'll be 1,340.095. But since you want to round to 2 decimal places, what is this 5 round the 9 to? 10. So it would be 1,340.10 because it rounds up. So you always look at the third decimal place to tell you what the second decimal place is going to round to. And that's our answer. So the reason why this is useful in real life is because if you put your money in the bank, all banks have an interest rate where you accumulate money just by having your money sit there in the bank. So here, they put it in an account that earns 5% annual interest. So without doing anything to their money, they just leave it in the bank for 6 years. They're earning 5%, which over time, they go from $1,000 to $1,340. So without doing anything, they just earned $340 just by leaving their money sitting in the bank. So every bank has an interest rate. In the last class, we looked up at the end what different interest rates are, so we can do that today. But Wells Fargo has a 0.01% interest rate. So it's not a lot that your money is accumulating, but interest rates change over time, and different banks have different interest rates. All right, so let's look at the next one. Brenda invests $4,848 in a savings account with a fixed annual interest rate of 5%. What will the account balance be after 6 years? So again, our formula is A times 1 plus R to the power of T. So what's A? 4,848. So that's our starting amount. That's how much we start with. What is R? 5%, but remember it's the decimal of that, so move the 0.05. And then what's time? 6 years. So let's plug everything in. So we have 4,848 times 1 plus our rate is 0.05 to the power of 6. So we have to follow our order of operations. What am I going to do first?
I have a question I'll answer after. Why do you put a 1 there? Is it just
It's the formula.
It's the formula?
Yep.
Okay.
So the formula just has a 1.
You do 1 plus 0.5, which is 1.05.
Yes, we do that first. So 1.05 because we do the parentheses first. No, we add. I just put a line there to tell you we do this first. I'll put it in a box. That's first. So 1 plus 0.05 is 1.05. What do I have to do next? I do the exponent. It's not getting distributed, but we do the exponent. So we put this into our calculator. 1.05 to the power of 6.
If you don't know how to do the exponent in the calculator, can you just do 1.05 times 1.05?
Yeah, but if it was 12 times, it would take you a long time.
Yeah.
So that's why you got to know how to use your calculator. Yeah. So make sure you know how to put this in your calculator. 1.340095. 6. You can, but just keep it in your calculator, because if you keep it in the calculator, you just take that answer and multiply it by 4848.
How come this time we went all the way to 6 and last one we stopped at 5?
It doesn't matter. You can write down as many as you want, but if you just keep it in your calculator, your answer will be as exact as possible. For your final answer, you just need 2 decimal places. Damien, what was your question? Yeah, that's what we got when we put that in the calculator. So then when we multiply these together, we get 6,496.78, and it's 0.783, so what would that round to? Just 78, because 3 is less than 5, so it stays the same. And that's our answer. Since we're dealing with money, we only care about 2 decimal places.
I have a question.
Yes. So we use the same formula. We need to find our starting amount, the rate, and time. So Leah invests $8,333 in a savings account with a fixed annual interest rate of 8%. What will the account balance be after 12 years? So what's our starting amount? $8,333. What's our rate? 8%, but remember we have to change it to a decimal, so 0.08. And then what is the balance, or what's our time? 12 years. So let's plug everything in. So we have 8,333 times 1 plus the rate, which is 0.08, to the power of t, which is 12. What do I have to do first? 1 plus 0.08, so that gives me 1.08. Then I do the exponent. So I have to put this in the calculator. So 1.08 to the power of 12. What do I get when I put that in my calculator? 2.518170011. And then what's the last step? Multiply it by 8,333. So just leave it in your calculator and put times 8,333. So what do we get as our answer? And 91 cents. So it's 0.991 or 0.911. 0.911. So it doesn't round up, it stays the same. So that's our answer. All right, the next one's a little bit different, but kind of the same. So Mr. and Mrs. Boyce bought a house for $96,000 in 1995. Real estate values in their area decrease approximately 4% each year. What was the value of their house in 2000? So our formula again is A times 1 plus R to the power of T. So I need the starting amount. 96,000. What is the rate? 4%. 0.04, so it's 4%, but we need the decimal. And then what's time? Awesome, 5 years, because we go from 1995 to 2000, so that's 5 years. Yes.
This time would you minus it because it's decreased?
Perfect. So we plug it into the formula, so it's 96,000. 1, it says decrease, so we do minus the rate, so minus 0.04 to the power of 5.
Wait, it's gonna be on our test.
So what do I do first to solve? The parentheses. So 1 minus 0.04 is what? 0.96.
What?
You're subtracting. Yeah, do it on the calculator. Yes, it does it in the calculator. 1 minus 0.04. What do I do next? The exponent. So 0.96 to the power of 5. 0.815376. Awesome. And then what's the last step? Times 96,000. So just leave it in your calculator and put times 96,000. So
$78,275.78.
awesome, 78 cents. In a calculator, we get 0.778. So then the 8 means we round up that decimal. 78,000. 2 decimal places. So this one, our number gets smaller because we're decreasing. So the value decreases every year. So that's why our number ends up smaller than the starting amount. All right, so we have one other type of formula. So whenever we see the words continuously compounded or compounded continuously, we use this formula. It's called, well, I call it PERT because it's P-E-R-T. So it's P, which is our principal, so that's our starting amount. So it's the same as the little a that we were doing before. Times E, which E is just a button in the calculator. It's like pi, where it's just like a fixed number. It's just a button in our calculator.
So if we didn't have a calculator, we wouldn't be able to do the test.
Correct. We need a calculator. R, again, is our interest rate, but remember, it's the decimal version. And then T is the time. So anytime we see compounded continuously, we use our PERT formula. So the difference between the other one and this one, compounded continuously, you earn money and it's put like back into your bank, and then that amount you earn interest on. So it like continuously grows and accumulates money every day. Yeah. So suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. So since it says compounded continuously, we use our PERT formula. So P is our starting amount. What do we start with? $3,000. E is just a button in the calculator, so it's not going to be anything. We just click that button. That's it. What's R? Our rate. So 0.05. And then what's T? 4 years. So we plug everything in. So 3,000 times E to the power of 0.05 times 4. So once I wrote everything down, plugged everything in, now I put it in the calculator. What do I put in the calculator first? Multiply the exponent. So I put 0.05 times 4. Everything else can stay the same. What's 0.05? Awesome. 0.05 times 4 is 0.2. Bless you. What do I do next? What do I do next? The exponent. So I put E to the power of 0.2. Now, everybody's calculator is different. In the phone or iPad calculator, so in the calculator, there's an E with an X button. So in the iPad calculator, I think you have to do 0.2 and then click that E to the power of X, like that. So this is how you would do it in the phone. in a calculator, my calculator has the e to the power of x button, and then I click 0.2. So make sure you know how to use your calculator. So in my calculator, the e to the power of x button, I have to click shift before I do that because it's like the little number. So I think yours is the same. You have to click shift first. So I click shift, e to the power of x, 0.2. Anybody do it in their calculator? So I got 1.221402. You're welcome. What's the last step here? Multiply by 3,000. So just leave it in your calculator and multiply by 3,000.
I'm gonna tell you. I wouldn't mind.
So I got 3,664.208, but what does the 8 round to? It rounds the 0 up to 1. So 0.21 is our answer. All right, so looking at the next one. Jasmine invests $2,658 in a retirement account with a fixed annual interest rate of 9% compounded continuously. What will the account balance be after 15 years? So compounded continuously means we use our PERT formula. So what's P?
2,658.
Awesome, 2,658. What's R?
0.9.
So 0.09, because remember we moved the decimal 2 times. And then what's T?
15 years.
15 years. So 2,658 times e to the power of 0.09 times 15. E is just a button in the calculator. It's like pi, but e is like, instead of pi being 3.14, e is like 2.7 or something like that.
What is P?
P is our principal, so that's the starting amount, what we start with. R is the rate, the percentage. T is time. So here, what do I have to do first? What do I do first? Multiply the exponent up here. So 0.09 times 15 is what? 1.35. What do I do next? E to the power of 1.35. So that gives me 3.857425. And we're going to keep it in our calculator, so it doesn't really matter how many numbers we write down. Yes, Jason?
So you just put e in your calculator and the exponent, and that's your answer, basically?
Yes.
On the test or quiz, how would they show work?
Same way I show work here. Just write it down.
So we put 1.35 to the 15th power?
No. It's e to the power of 1.35. Because I multiplied 0.9 times 15 and got 1.35. And then when I put e to the power of 1.35, I got 3.857. And then I multiply that by 2,658. And I get 10,253.037. But what does the 7 do? Do I round up or down?
0.4.
It rounds it up to 0.04. All right, so let's look at number 4. Maria invests $6,154 in a savings account with a fixed annual interest rate of 8%, compounded continuously. So what formula do we use? PERT. What will the account balance be after 10 years? So I need P, R, and T. What's my principal? 6,154. What's the rate? 0.08. And what's the time? 10 years. So plug everything in. 6,154 times e to the power of 0.08 times 10. What do I do first? multiply the exponent. So e to the power of 0.8. What do I do next?
E times 4.8 or e to the power of 0.8.
E to the power of 0.8. So e to the power of 0.8.
That was 0.08.
I multiplied it times 10. So 2.225540. And then what's the last step?
Multiplied by 6,154.
So multiply by 6,154. And what do we get as our final answer? $13,695.90. How much cents? 98 cents. Because it's 0.978, so the 8 would round the 7 up.